Hi everyone, bonjour. The IB Crocodile is here. Welcome to my YouTube channel. Let's have a look at this question here. Past paper IB Physics Higher Level Paper 1 Time Zone 1 May 2023 session number 7. A block of mass 2 kilograms is placed on a trolley of mass 5 kilograms moving horizontally. A force of 8 Newton is applied to the block, which slides on the surface of the trolley. The frictional force between the trolley and the ground is 0, so assume frictionless surface. The trolley accelerates at a rate of 1 meters per second squared. What is the coefficient of dynamic friction between the block itself and the trolley? Meaning there is a friction between the block and the trolley, but there is no friction between the trolley itself and the ground. So obviously this is Newton's second law or first law, forces, I see forces, acceleration, keyword here, acceleration and forces. So that means this is Newton's second law. So let's start to lay out the forces in the system, and let's start with the block. So what are the forces acting on the block? Okay, we see here already 8 Newton applied on the block, but then there is the weight down here. Okay, let me just get another color here. So there is the weight of the block vertically down, and I'm going to call it mg. So mg. So let me call small m the mass of the block, and let me call big M the mass of the trolley. So now I have mg down, and then since there is a surface of contact between the block and the trolley, so there is a normal force perpendicular to the surface, and I'm going to try to draw it as equal in magnitude, or equal in length. So this vector, this up, or this is normal force vector, should be equal in length to the weight, because there is no motion in the vertical direction, which means the net force on the block in the vertical direction is 0. And also, since there is a request to find the coefficient of dynamic friction between the block and the trolley, so that means there is a friction, let's say opposite to the motion. I'm going to put the friction here, opposite to the motion, and let me call it F sub F. So that's all the forces. This is basically all the forces acting on the block. So let's apply Newton's first law on the block in the vertical direction. Okay, so I'm going to say, okay, I'm going now to apply Newton's first law, which is the net force equal to 0, and that is on or in the vertical direction. The vertical direction. So we can say, okay, let's say the upward direction is positive, and down is negative. So you can say the normal force up minus mg down equal to 0 implies the normal force equals to mg. And that will help me to formulate the frictional force, right, between the block and the trolley, and then we can try to find the coefficient of dynamic friction somehow. So I can continue here. So okay, since the frictional force is equal to mu sub d, because here it's dynamic friction, so I say, okay, dynamic friction. So there's a motion. So mu sub d times the normal force F sub n. But then from here, we got F sub n equals to mg small m, which is the mass of the block. So we can say the frictional force technically is mu sub d times mg. And let's just call this equation 1. Now let's now focus on the trolley itself. Now there is no friction between the wheels of the trolley and the ground, and this 8 Newton actually applied on the block itself. In the same time, there is acceleration of 1 meters per second squared of the trolley. So if the trolley has acceleration or accelerates, and let's say, obviously, I mean, let's assume acceleration is going to be this way. I mean, you know, obviously, we have 8 Newton force this way, and right, and that causes somehow an acceleration of the trolley. So it must be a net force on the trolley, right? Because there is acceleration. If there is acceleration, according to Newton's second law, there should be a net force or resultant force or unbalanced force. So where is that force? The answer is using Newton's third law. So Newton's third law states that for every action, there is a simultaneous reaction equal in magnitude and opposite in direction, meaning that frictional force has, you know, a pair or is a part of a pair of forces. And let's say this force would be in the right direction, and let me call it small f sub f prime. So f sub f prime, this is actually the force that acting on the trolley, and that actually makes the trolley moves or moving or accelerating to the right. And this force here equals in magnitude, you know, to the frictional force between the block and the trolley. So let's apply now Newton's second law. So I'm going now to focus on the trolley, right? And this direction here. And let's say, okay, this direction is positive and the other way is negative. Now on the trolley, say, okay, net force in the horizontal direction equals to big M, okay, times A. So because now I focus on the trolley, so I'm going to use big M, which is 5 kilograms. And we know the acceleration. So basically the right-hand side is totally here, right? So the 5 kilograms times 1 meters per second squared. Now what is the net force? The net force is the vector sum of the physical forces acting on the trolley, which is basically this single force here. This is really the only single force acting on the trolley itself. This 8 Newton, you know, acting on the block. I cannot, of course, obviously they are not moving in the same time. Like they're not moving as one body, right? They are not moving as one body. So we can say, okay, so the left-hand side here is going to be the f sub f prime, which is the equivalent to the frictional force between the block and the trolley. And okay, so since now we've got a formula from equation 1 here for, you know, got the frictional force equal mu sub d times small mg. So I can replace now the frictional force f sub f prime by mu sub d times small m times g equals to 5. Now small m here is 2 kilograms. G is 10 meters per second squared, just in paper 1. You can always assume that. Usually in the beginning of the paper, you know, they'll tell you, you know, assume take G as 10 meters per second squared. This is a non-calculator paper, just to make your life a bit easier. So 2 times 10, okay, so that basically 20 mu sub d equals to 5, implies mu sub d is 5 over 20, which is 1 over 4, which is 0.25. So the answer to this question is C. So the bottom line, you know, whenever the acceleration is applied or wherever the acceleration is applied, this is where you apply Newton's second law. Thanks for watching and have a nice day.